Today's transformation is going to be reflection. Reflection is a little more interesting than translation. It's maybe what you referred to in 6th or 7th grade as a flip transformation, but we're going to use the formal name now of reflection. And reflection simply maps a point, an original point, a pre-image point, P, onto another point, P primed, by reflecting it in a given line. So a point is always reflected in a line. And if we have shapes that consist of more than one point and we're going to reflect it, we reflect one point at a time. And then reconnect the dots and we're done. So basically, P is my original point, P primed is my image point. The only exception of a reflection is when the original point is on the line of reflection itself. If the line of reflection, often referred to as the mirror, if the point is on that line, then the pre-image is actually the same as the image because there's no place to reflect it. There's no distance to do it. We know from our study of perpendicular lines that we always go perpendicular to the line, and so these distances are equal and they're both perpendicular lines. That in fact, M is the perpendicular bisector of the segment PP primed. So that's what a reflection does. Now let's take a look at some examples of this. I have a triangle. It's all graphed for us already here, ABC, and we want to reflect it in the line x equals 3. Now, sometimes we reflect in an axis. And you recall our axis. This is my x-axis. This is my y-axis. And that's usually pretty easy. Sometimes we reflect in a different line, and we generally stick with vertical and horizontal lines. There are going to be two exceptions we'll discuss in just a minute. But x equals 3 is a straight either vertical or horizontal line. The question is which one? Is that vertical or horizontal? So what I'm going to do is figure that out very quickly. Well, my x-axis is here on the horizontal. There's my x-axis. So x equals 3. It wouldn't make sense to be up here because the x doesn't equal 3 all the time. That's not what it's saying. Okay? What makes sense is that x equals 3 when we look at it. If I go back to my pencil tool here. Here we go. If I go back to that x equals 3, there's what I want, is where x equals 3, or right, whoops, hello, try that again, where x equals 3, right there. That's the line x equals 3. A x equals line is perpendicular to the x-axis. A y equals line is perpendicular to the y-axis. So it's perpendicular to the axis of the same name. Now that I know that's my mirror, reflecting the points is actually pretty simple because the vertical line perpendicular is horizontal. So point A here is 2 units left of my mirror, x equals 3. So I'm going to go 2 units right to get A primed. Point B is 2 units right of my mirror, so I'm going to go over here for B primed on the left. C is 1 unit left, so I'm going to go 1 unit right. And when I connect my dots, I get an exact duplicate of my original triangle, but flipped over that line, as if that were a mirror. So it's an exact mirror image of that original triangle. And when we label the points, it's always useful to help label the points too, by the way. So A was at 1, 3. Now A primed is at 5, 3. B was at 5, 2. Now this is at 1, 2. B primed is at 1, 2. And C is at 4, 1. So there we go. So we've got our new coordinates and everything. We've got a beautiful new triangle. Same triangle this time, but this time we're going to reflect in the line y equals -1. So again, indicate where it is. It's going to be perpendicular to the y-axis at -1, or right there. And again, fairly straightforward. C is 2 units above, so 2 units below for C primed. A is 1, 2, 3, 4 units above, so 1, 2, 3, 4 units below for A primed. And B is 3 units above, so 3 units below the mirror, B primed. Again, we're getting an exact duplicate of my original triangle, just flipped over that particular mirror at y equals -1. And we could find the coordinates of the points just by counting boxes. This is 1, -1, 2, 3, 4, -5. B primed is at 5, -4. And C primed is at 2, -3. So we've got our coordinates. Fairly straightforward. Not too difficult to do. Reflecting the line y equals x is a little more challenging because it's not a horizontal or vertical line. It's a diagonal line at 45 degrees. So what I want to do when I do this reflection, f is at -1, 2. So -1, 2, there's f. Now, since this line is 45 degrees going up to the right, my mirror, my reflection has to be on the other 45 degree coming down to the left. You'll notice that's 1.5 diagonals away from my mirror. So I'm going to have to go 1.5 diagonal on the other side to find f primed. G is at +1, 2. +1, 2. So G primed is going to be 1/2 a diagonal from here, so 1/2 a diagonal from here. There's G primed is at 2, 1. By the way, F was at -1, 2. F primed is at 2, -1. Now, when I look at my reflected segment, though, it's definitely not in the same orientation. It's not a translation. That's a reflection. It went from being a horizontal segment to being a vertical segment. Okay, so that's what it did. So reflecting, instead of on a diagonal, on a 45-degree diagonal, means working on the opposite 45-degree diagonal to do our reflection and count the number of diagonals instead of the number of just squares. That's okay. We can do it that way, and we can do it pretty easily in the coordinate plane. But you might notice that F was at -1, 2, and F primed was at 2, -1. G was at 1, 2, and G primed is at 2, 1. So there's actually a rule that helps us with this. And that's what we see here. Specifically, we're looking at, right now, this rule. If we're reflecting in the line y equals x, and every point AB goes to the point BA, we simply switch the x and y coordinates when we reflect in the line y equals x. If we reflect in the line y equals -x, which, by the way, in case you're wondering, is the other 45-degree diagonal, that's y equals -x. Okay. If we reflect in the other diagonal, you very quickly see that the image point, we not only switch the order, but we switch the signs of the point as well. So AB goes to -B, -A. Reflecting in the x and y axis, there are rules for that as well. I would not recommend spending time memorizing those rules because reflecting in the axis is so simple that you can do it very quickly, which is with a sketch. You don't need a whole lot going on. The diagonals tend to be a little trickier, and the rules can be helpful. If you're a rule person, you might want to memorize those rules. Reflecting the x-axis changes the y-coordinate. Reflecting the y-axis changes the x-coordinate. It's pretty much the way that it works. Changes the opposite coordinate. So again, graph something after reflection in the x-axis. The biggest thing is remembering which is the x-axis. There's the x-axis. That's my mirror. Again, L primed is down here. K primed up 4, so down 4. J primed up 3, so down 3. You notice the x-coordinates do not change for the points, but the y-coordinates switch from positive to negative. So J primed was at 1, negative 3. K primed is at 4, negative 4. And L primed is at 3, negative 1. And sure enough, that's where we wound up. Reflecting the x-axis changes the y-coordinates. Reflecting the y-axis changes the x-coordinates. Reflect this time in the line y equals negative x. Now again here, we can draw in our mirror pretty quickly and we do our reflection manually by counting diagonals. L is 1, 2 diagonals over. So we could go 1, 2 diagonals over here for L primed. Or we could just take the points and say J primed, we have to switch the order and the signs. K primed, switch the order and the signs. And L primed, we switch the order and the signs. And sure enough, when we do this, K primed is 1, 2, 3, 4 diagonals. So 1, 2, 3, 4 diagonals. Here's K primed. J primed is 1.5, 2 diagonals. 1, 2 diagonals. There's J primed. And again, it's an exact copy of the original, just flipped over that line. We can do it using counting boxes. We can do it using the rules. Either way really is effective. Reflection postulate. Reflection is another rigid transformation. So translation was rigid. Reflection is rigid. We get an exact copy of the original after the reflection. If the copy doesn't look the same as the original, you've probably made a mistake, and go back and check what's going on. Now, along with lines of reflection comes the idea of lines of symmetry. And symmetry is something you should be very familiar with. I know you've worked on this before. But identifying lines of symmetry is important. How many lines of symmetry does each hexagon have? In other words, how many different ways is it symmetric? C is the easiest one, so we'll start with C. There's just one line of symmetry. If I reflect over that line, if I fold it over that line, I get the same thing. A is a little trickier. I have one line of symmetry here, but I have a second line of symmetry approximately here. Out there. So if I fold over either one of those lines, I get an exact duplicate of the original. For B, I have a whole lot of lines of symmetry. I've got this one, this one, this one, this one, if I slide over just a little bit, this one, and this one. I actually have 6 lines of symmetry for B because it's a regular polygon, meaning all the sides are the same, all the angles are the same, so the number of lines of symmetry is the same as the numbers of sides. So identifying lines of symmetry is something we can do. Let's look at a couple more for practice. 12, how many lines of symmetry do you think you're going to see there? Go ahead and sketch yours in on your notes, and then I'll come and check those tomorrow. 13 and 14, same deal. See if you can find how many lines of symmetry there are. I'll tell you for 14, this is an isosceles triangle. Those two sides are congruent. That may help a little bit. So go ahead and try to find your lines of symmetry. Sketch them in on your notebook. I believe these are all in your student journal as well. And I will check those in class tomorrow. And that ends our lesson for today.